Let's see if we can find the same risk and return of a portfolio based on its weights using these analytical formulas that I've added to our list up here. Before we've calculated our statistics on Kellogg, on ExxonMobil, and on the portfolio, and we'll see if we can get the same answers for the portfolio. So the first thing we're going to need is this equation for the correlation of returns. So let's just put it right here. And that's the correlation of the returns on Exxon and the returns on Kellogg. I said those backwards. It really doesn't matter which order we put those in. The math is the same. And we call that correlation R. So if you see R squared somewhere, it's just that number squared. And it talks about how closely related are these two lists of data. To get the expected return, we're going to use the same exact thing that we used below for each of these periods. Again, if we put $100 into this portfolio, 80% went into this stock, then those $80 are going to see a 31% loss, and the $20 are going to see a 22% gain for a portfolio return of 20%. We can apply the same things to the expected returns by putting that formula in here. And we do get the same answer. Let's make sure that that's the same answer to several decimal places. And of course it is. Now let's go back and look at the standard deviation of returns. This is a big, long, ugly formula, but we can just copy it and paste it into this cell. Hopefully everyone's seen that formula in a finance class by now. And again, we get the same answer. Let's check that to several decimal places. And so the same thing we did by calculating the portfolio returns in each period and then treating that like a single stock, we were able to duplicate by using these equations, these formulas up here, without having to calculate the portfolio. That's going to become very important as we move to more and more stocks in our portfolio beyond just two. So I'm going to gray out this portion since we don't really need that going forward. Now let's step up here and create the envelope again of all the possible outcomes. So I'll make a column for the weight in Kellogg and the weight in ExxonMobil and the risk of the portfolio. To get that P as a subscript, I'm going to highlight the P, go to font, and make it a subscript. So that's the risk of our portfolio, and then the expected return of our portfolio. Again, I'm going to use that trick by putting space, parentheses, hit F2, go left, and delete the space. So if the weight in Kellogg varies from 0% to 100, we can calculate the weight in ExxonMobil. We can copy the formula that we use to calculate the risk of the portfolio. And we're going to change the reference to weights to columns O and P. Then we're going to lock the references to anything in column D, E, and G. And we should be able to copy that down. So there are a few things we can check. Let's change it to a percent, and see if 100% in ExxonMobil gives us the same risk as ExxonMobil stock, and it does. 100% in Kellogg gives us the same risk as Kellogg stock, and 80% in Kellogg gives us the same risk as our portfolio, which was shown at 80%. Then we can do the same thing for the expected return. Of course, double check that 100% ExxonMobil has the same return as the stock did, 100% Kellogg has the same return as the stock did, and 80% Kellogg has the same return as the portfolio did. If we create a risk return plot for this data, it will look the same. And we can see the whole envelope.